When trying to evaluate limits, especially when this is a number, the first thing to do is substitute that number in for x and see if you get a numerical result. If you do, you're done. If you get something like division by 0 or infinities, then you need to try something else. So in here, if I substitute a 2, it's going to be 4 minus 8 plus 4 over 4 minus 4. So I can see that the denominator is already going to be causing trouble. And in fact, this is 0 over 0. Which is called undetermined form. So it says 0 divided by 0 really doesn't make sense. We don't really have a definition for that, so you really need to try something else. The next thing to try is algebra. So try to do some algebra on each one of these, like for example factoring. So the denominator can be factored as x plus 2 and x minus 2. And it's actually that term right there that's causing the trouble. Because when you substitute a 2 in for x, that's causing division by 0. Now factor the numerator, and it can be factored as x minus 2 times x minus 2. And then the x minus 2 can be cancelled, and hopefully the trouble that we were having just got cancelled. So try it again. Now substitute the number in again, so substitute in a 2, and we get 2 minus 2 for the numerator and 2 plus 2, so that's going to be 0 divided by 4. And 0 divided by 4 is equal to 0. And so that would seem to be the answer. Now we can take a look at the function and see if 0 looks right. So we're going to graph this function. Since it's got more than one thing in the numerator, use parentheses to say, here's what's in the numerator. X squared minus 4x plus 4. The same deal with the denominator. Put in parentheses, x squared minus 4 parentheses, and then we're looking at where x is equal to 2, so I can change the window to be close to that, like 0 to 4, and then the answer seems to be 0, so we need to stay close to 0, so negative 2 to 2, that should do it. And then take a look at the graph, and so as the x gets close to 2, sure enough, the function is very close to 0. So you can see it graphically. You can also see it numerically if you trace. Well, when you substitute in a 2, you get no answer, which is what happened to us over here. We substituted in a 2 and we got nothing. So actually the graph looks like this. It's undefined at x equals 2. And then it keeps going. The graphing calculator has that numerically, but it doesn't have a hole in the graph. It doesn't understand that. So we need to understand that. And then by doing this factoring and eliminating this, we basically said, okay, what happens at that point, as far as limits go, what happens at that point doesn't really matter. What matters is, as you get closer and closer and closer to where x is equal to 2, then where are you being led? And you need to do it on both sides. As you get closer and closer and closer to where x equals 2, where are you being led? To the number 0. And finally, you can see it numerically if you trace and say, well, what if I wasn't exactly at x equals 2, but I was close? So over here on the left side, 1.9 is giving me a result that's very close to 0. Get closer, and it gets closer to 0. Get closer, oh, that's too close, 1.99. And we're very close to 0. And the same thing happens on the other side if I use 2.01 or something like that. Then the result is very close to 0. So it looks like this 0 is correct.